Okay, so the part that we left, I told you to write repeat. So there it was that, suppose I'll make a graph, okay, time distance graph. As you know, the niche wala part is our time in minute, and upar wala part is our distance. Okay, so suppose this is a uniform motion. Okay, this is a uniform motion, and suppose this is my, so this is an uniform motion, means I'll get a straight line. Okay, so suppose this is the straight line. Let me make the straight line. So I'll get a straight line like this. Okay, okay, so this is this bar is straight because it is uniform speed. Okay, my speed is uniform. Okay, suppose I'll take any point, suppose from this point. Okay, from this point to this point, I want to find out the velocity or speed. Okay, this to this point. Okay, this to this point. What I'll do, okay, so here what I'll do, why it is not going, wait, so here what I'll do, I'll from this point, okay, from this point I'll make a straight line, okay, parallel to x axis. Okay, and from this point I'll make a straight line parallel to y axis. Okay, like this. So it will make a triangle. Okay, so let's draw this and wait, this, and from this to this. Okay, so this is making a triangle. Okay, acha. So what is this to this? What is this to this? This to this. Can we suppose this time means from this to this? Okay, this to this. Suppose this time is our, suppose t2, and this to this is our t1. Okay, so this to this is a t1, and this to this is a t2. If I subtract t2 minus t1, okay, so from t2, matlab this to this, the bigger one, t2 minus t1, this to this. If I subtract this, okay, will I get this to this? Yes, I'll get. So t2 minus t1, my time taken from A to B. Suppose this is my A, this is B. Okay, from A to B the time taken was t2 minus t1. Okay, and this to this, from this to this. Okay, so this is which distance? Suppose the total distance, matlab this, the whole. Okay, suppose this is your, suppose this is our S2, and this to this is my S1. Okay, this to this is my S1, and this is, let me show you, this to this, like niche to this much is S1, and this to this is my S2. Okay, so if I'll subtract S2 minus S1, okay, S2 minus S1, will I get this to this? Yes. So this is my distance covered from A to B, that is my S2 minus S1. Okay, acha. So we already know that our speed or velocity is equals to distance by time. Okay, so if this is our distance and this is our time, can I say that my velocity equals to, or speed equals to, S2 minus S1 by T2 minus T1? Yes, we can say that. So this is how you can get your velocity from any point from a graph. Okay, so if you want to find out velocity from this to this, okay, so just make the triangle, I made the triangle. Okay, and we know that this to this is a t2 minus t1, this to this is a s2 minus s1. So s2 minus s1 minus t2 s2 minus s1 divided by t2 minus t1 is our velocity covered. Okay, so this much I think you understood the part we left, that I told you to write repeat there. So this is the part that we left. Okay, okay, now we'll read equations of motion by graphical method. Okay, so there are actually three equations. Okay, you have to remember. When an object moves along a straight line with uniform acceleration, it is possible to relate its velocity, acceleration during motion and the distance covered by it in a certain time interval by a set of equations known as the equations of motion. For convenience, a set of three such equations are given below. Okay, so what I said, you have to consider acceleration, okay, velocity and distance and time. Okay, so your acceleration is, our acceleration is denoted with, acceleration is denoted by a. Okay, and our velocity is denoted by u and v. Okay, so u is our initial velocity and v is our final velocity, you know already. Okay, final velocity. Then what you have to consider, you have to consider time, that is t. Okay, t equals to our time. Okay, these three values you will need to consider, and also s stands for our distance. Okay, s is our distance. Okay, so there are three equations. So what are they? First one is v equals to u plus a t. Okay, so this is our first equation. V is, we know v is final velocity equals to initial velocity plus acceleration into time. Then s equals to u t plus half of a t square. Okay, this is our second equation. Our distance equals to, okay, initial velocity into time plus half of acceleration into time square. Okay, then next one is our 2as is equals to v square minus u square. Okay, that means square of final velocity minus square of initial velocity is equals to 2as, 2 into acceleration into distance. Okay, so these are the three relation equations you have to remember. This is very important. Okay, so let's come to equation for velocity time relation. Okay, consider the velocity time graph of an object that moves under uniform acceleration as, okay, like before we did. Okay, suppose let me show you. In next you are having derivations, how these equations we got. Okay, so let us consider this. Okay, suppose our vehicle is at a. Okay, so our vehicle is at a, this point. Okay, this point. So so from a to b, this shows that it is in uniform motion. Okay, so this is in uniform motion. Acha, what is our initial velocity? Suppose this to this line is our velocity line. Okay, so what is our initial velocity? This is our initial velocity a is our initial velocity here. Okay, so this is our u, okay, and then increases to v, means it increases to this point. This point it increases our velocity. So our velocity is final velocity is at b, that is b, okay. So at u, this is at a, this is our initial velocity. At b, this is our final velocity in time t, okay. Acha, what is the time? This to this, so this is our time. At c, this is our time. Then the velocity changes at a uniform rate a, okay. So our acceleration is a, the rate is a, okay. A equals to acceleration, okay. So a is our acceleration. Now in figure 8.8, like in this figure, the perpendicular lines b, c and b, e are drawn from point b, okay, which is points b, c, okay, this point, and which point b, e, b, e, this point, okay. This point and this point, okay, are drawn very perpendicular, okay, lines from point b on the time and velocity, okay. So this to this our vehicle reached from here, okay, from here to here our vehicle reached, okay. So from b point, okay, we drew perpendicular lines like here, and from here, okay, b, e and b, d, these are perpendicular lines we drew. Now then, so that the initial velocity is represented by OA. So what is our initial velocity? OA. O, from O to A, this is the initial velocity, yes, because at A this is our initial. Suppose this is 1, this is 2, and this is 3, okay. So O to A is 3, and if we'll say A point is 3, okay. So whatever, so O to A is 3, means O to A is our initial velocity. Then the final velocity is represented by b and c, okay. B to c, let me show you. From b, from this point to this point is our final velocity, okay. So this is our initial velocity, this is our final velocity. That means from base to this is our initial velocity, from base to this is our final velocity. Then OC is our OC, I told you, okay. OC is our time, the maximum time we went at C, so OC is our time, okay. OC equals to time. Then BD equals to BC minus CD or not? BD, where is BD? This is our B. Acha, let me write it again because I messed it up. So this is B, okay. So BD is equals to BC minus CD, okay. This BC, okay, from here to here, okay, last, from here to here, this is BC. We want the length of BD, okay. So this is BC. If from BC I'll subtract D and C, okay, CD, okay. From BC I'll subtract DC, okay. Will I get BD? Yes, I'll get, okay. So let me write it. BD is equals to BC minus CD, okay. This then represents the change in velocity in time interval t, okay. What is BD? BD shows us the time interval, change in velocity, okay. From O to A our velocity was constant, from A to B it changed, okay. So that means our BD shows the change in velocity, okay. BD shows our change in velocity, okay. Then let us draw AD parallel to OC, okay. AD, this is our AD, this is our AD parallel to OC, okay. Where is OC? This, okay. AD is parallel to OC, I told you before, okay. AD is parallel to OC. Now from the graph we observe that BC equals to BD plus DC. Okay, where is BC? BC equals to BD plus DC, na? This, from this equation we can get BC equals to BD plus CD. Okay, acha. So let me write it actually. Let me write it. Wait a minute. So BC is equals to BD plus DC. Okay, acha. BD to BD. DC, can I write it as OA? DC, where is DC? This to this, this to this, DC. Is it OA? Yes, it is OA. DC equals to OA. This is a rectangle, so opposite sides are same, so DC equals to OA. Okay, acha. Can I write BC as V? BC. So BC means from this to this. BC as V, can we write? Oh, yes. Okay, I told you already, BC is our final velocity, that is V. Okay, and what we'll write? OA, that is the OA that we wrote, the OA. Is this our initial velocity? Yes. So BC is V, DC is U, we got. Okay, so can I write now finally that V equals to BD plus U? Yes, implies that BD is equals to V minus U. I can write. Okay, BD equals to V minus U. Okay, acha. So this much I wrote. Then from the velocity time graph, the acceleration of the object is given by, we know that acceleration equals to, wait, let me erase this. Acha. We have the formula, that is acceleration is equals to change in velocity divided by time. Okay, so what is our change in velocity? Is my change in velocity is BD? Yes, our change in velocity, my change in velocity is BD, na? From C to D it was okay, from C to D it was constant, but D to B means B to D it changed. Okay, that's why it is inclined. So BD, I can say this is my change in velocity. Okay, so I'll write BD, okay, divided by time. Time is my AD. Okay, we discussed earlier, time is our AD, time taken. AD, this is our time taken. Okay, so AD, acha. BD divided by AD, can I write OC? OC, BD, can I write OC? Yes, rectangle. Okay, opposite sides are same. AD equals to OC, I can write. So this is, wait, this is OC. Okay, BD by OC. So acceleration I got BD by OC. Acha. Substituting OC equals to T, we get, acha, OC is a T or not? OC is a T. OC is a T. Okay, suppose I'll substitute OC by T, finally I'll get A equals to BD by T. I'll get BD by T or not? Okay, so finally, wait. So finally I got A equals to BD by T. If I'll substitute, okay, if I'll substitute, implies that BD equals to AT. Now see, here I am getting BD equals to AT. Here I am getting BD equals to V minus U. Can I equate this? So that means our AT equals to V minus U. Okay, that means, can I write our V equals to, can I write our V equals to U plus AT? U plus AT? Yes. Okay, so this is what we derived. This is our first equation or not? This is our first equation that we wrote. Okay, so this is our first equation, we got it, we derived it, V equals to U plus AT from this diagram. Okay, hence proved. Acha. Now second one we will prove. Second one we will prove. Wait, let me erase this. So first equation we proved, second one we have to prove. Achha. Let us consider that the object has traveled a distance s in time t. Okay. So now here in second equation our s came. Okay. S equals to, I told you, s equals to our distance. S is equals to our distance. Okay. Achha. Let us, the distance taken by this same vehicle is s. Okay. Now so time is t, same, acceleration is a. The distance traveled by an object is obtained by the area enclosed within OABC. Okay, we read it before that the distance covered by the car is the area of OABC. Okay, OABC matlab which area? This is OABC, this area. Okay, let me hatch it. Oh, wait, let me hatch it. This area. Okay, this area. If we'll find out this area, then we'll find out the distance covered by the car, yes or no. Okay, so this area. Okay. Okay, now how to find out? We will divide this area into two parts. One is this rectangle area, another is triangle area, and we know very well how to find out. Acha, how to oh, sorry. So how to find out rectangular area? How to find out this rectangle area? Length into breadth. Rectangular area is length into breadth. Okay, so can I write OA into OC? Yes, OA into OC is rectangular area plus triangular area. What is triangular area? Half into base into height. Okay, so half into base is our AD, height is our BD. Okay, height is our BD. So now we know that our OA is what? Our OA is our initial velocity. Yes. Acha. OC is our what? OC is our time. Okay, OC is our time or not? This OC. This is our time taken or not? Okay, so OC is our time. Now, acha. BD equals to 80 we got in first equation. We derived BD equals to 80. Yes. Acha. Now, acha, AD. What is our AD? AD is also is our time. Okay, AD equals to OC equals to time or not? Okay. Acha. Now let's write it again. So S equals to, means this is S. Now we are finding out S. S equals to U into T. U into T plus half into T into 80, means 80 square. So did I just get the second equation? S equals to UT plus half 80 square. Okay, so this is our second equation derived from the same diagram. Okay, so let me erase it and we will prove the third equation. Okay, so here we'll prove the third equation. Okay, acha, in the second equation we got, okay, we first find out the area of this and second this and we added it. Acha, if we won't do this, if we won't divide it into two areas, if we will do how? Now, finding out the area of a trapezium. Is this a trapezium? The whole, is it a trapezium? Yes, this is a trapezium, and the area formula of a trapezium is half into sum of parallel sides into height. Okay, so let's write it. Okay, so if we will find out as the trapezium area, okay, by not finding out rectangle and triangle, trapezium area. Can I write it as half into OA plus BC into OC? Okay, yes, I can write. Okay, OA is our one parallel side, BC is our another parallel side, and OC is our height. Okay, now we know very well that, again I am repeating, OA is our T. Sorry. OA is not our T. OA is our what? OA is our initial velocity. OA is our initial velocity. So BC is our final velocity, and OC is our T. OC is our T. Okay. So that means let me write it here only, because there won't be any space left. Acha. That means, can I write S is equals to half into U plus V into T? Can I write, or U plus V into T divided by 2? Okay, this is our S. Okay, so this we got. Again, let me raise it from first equation. Okay, can you remember the first equation? From first equation, what did you get? We got that V equals to U plus AT. We got V equals to U plus AT. Acha, if I'll find out T, okay, so that means AT is our V minus U, implies that T equals to V minus U. This is V. Okay, the V minus U divided by A. Okay, is this our second equation? Yes. So if now what I'll do, I'll put this T value here. Okay, this T value I'll put here. Okay, let's see what I'm getting. Okay, just remember this value, I'm erasing it. V minus U by A. T equals to V minus U by A. So let's put it in the equation. V minus U by A. So A is equals to half into U plus V into V minus U by A. Okay, so if you solve it, you will get, implies that A is equals to V plus U into V minus U divided by 2A. And if you substitute, you will get 2AS is equals to A plus B. This is which identity? A plus B into A minus B. That is A square minus B square, means U square minus B square. So did we just get the third equation? Okay, so this is our third equation got proved. Okay, so this is what, these are the three equations. Okay, I don't think so proof will come. Okay, derivations, I don't think so it will come. Derivations won't come. You just have to remember the three equations. Okay, and then after that, some problems we are having. So I am not explaining the problems. You need to understand it by your own. If you are having any doubts, we can discuss it later. Okay. Acha. Now what we are having? We are having uniform circular motion. Circular motion is nothing. So there is nothing in circular motion. Okay. Like there can be, if there can be linear motion, there can be circular motion. Okay. So we can move in different paths. We can move in different kinds of paths. Like we can move like this. Okay. Suppose you will start from running from this point. You will go this. Okay. This is a linear, or you can say this is a rectangular track or rectangular motion. Okay. Like that. If we will run like this in this type of track, this and this. Okay, so suppose from this you will start, you will go like this and this. So this is a hexagon, so we can say this is a hexagonal track. Okay, So octagonal track, pentagonal track you can have. So finally we are having a we are also having a circular. Acha, wait. So we are having a circular track as well. Okay. So this is a circular track. If you start here, okay, you will be going from here like this, and this is your circular motion. Circular motion. This is a circular motion, and we are having many examples of circular motion. Okay, when we swing a stone, okay, tied with a thread. Okay, you can see in the book. Okay, there is a image. A boy is swinging a stone, holding the thread. Okay, so this is a circular motion. Okay, when an athlete is running in a circular track, this is a circular motion. Okay, and many circular motions are there. So these are the circular motions. So there is nothing actually in circular motion. Okay. Acha. So we know that velocity or speed. Okay. Velocity or speed is equals to, this is v, okay, is equals to distance by time. Okay. So in a circular path, okay, in a circular, suppose you started from here, you went round and round and round, and you came here. Okay, what is the distance you covered? What is the distance you covered? This is what? This is the circumference of the circle. This is the circumference of the circle. So what is the formula for the circumference? 2 pi r. Yes. So d equals to 2 pi r divided by t equals to time. Okay, 2 pi r by time. So in a circular motion, so this is your formula. Okay, in a circular motion, your velocity or distance is equals to 2 pi r by t, 2 pi r by time. Okay, when an object moves in a circular path in uniform speed, its motion is called uniform circular motion. You have to underline that. It is in the page after the formula it is written. You have to underline that this is the definition of the circular motion. Okay, so if you carefully note, on being released, the stone moves along a straight line tangential to the circular path. Okay, let me show you actually this. You can't imagine that. Let me show you this. Let me show you. Achha. So this is a circular. Suppose someone is just holding the thread, and this is the stone. Okay, stone is moving like this. Okay, suppose you moved like this and you threw. Okay, means you are moving and you are throwing. Na, we throw the stone. So when you are throwing, you see, okay, your that stone will go in a tangential. Tangential matlab touching the circle straight. Okay, so this is the tangential. Okay, means it is tangent to the circle. Okay, this means tangent. Just suppose this is the circle, this is the tangent, this is another tangent, this is another tangent. Okay, these are the tangents touching the circle. Okay, so this is the tangent, this is also the tangent. Okay, so tangentially it moves. Okay, it will go like this. Okay, in a straight path it will go. Okay, so this is what it is written. When an athlete throws a hammer or a discus in a sports meet, he or she holds the hammer or the discus in his or her hand and gives it a circular motion by rotating his or her own body. Okay, so you must have seen in athletes, when they will be throwing any discus or something, they actually they move in a circular path. Okay, like earth rotates in own axis, like that they will be circulating, and after that they will throw. Okay, so just like the piece of stone in the activity described above, there are many more familiar examples of objects moving under uniform circular motion, such as the motion of the moon and the earth, a satellite in a circular orbit. So there are many circular motions a cyclist on a circular track at constant speed, and so on. Okay, so there are many examples of circular motion. Okay, so this much and your chapter is over. I hope you understood everything, and your homework is to uh, just try to understand the problems. Okay, try to understand the problems, and if you are having any doubt you can ask me. Okay, but don't just leave it, okay, you have to practice. Okay, and if you one day if you tell me, ma'am, I didn't have any doubt, I understood everything, then I'll be the happiest person on earth. Let it be. So this is your chapter. Your chapter ends here. So these are the graphs and all that I made you understand. Okay. Okay, bye bye.